In this video, we're going to see one of the common aspects which we usually find on board our ships, either in the instrumentation panel or any pressure or temperature tapping, especially in the boiler. We have a pressure gauge before which the pressure tapping from the boiler connecting the pressure gauge will be curved or looped. So the topic for the day is on the siphon tubes or siphon loops. What are they and why are they provided? Let's watch it and understand it better. The picture here shows various forms of siphon tube or the siphon tube arrangement. So you can find such arrangements on a boiler or a hydrophore or pumps or any other pressure tapping arrangement where you have to read the pressure. Let's say the main engine lube oil pump, and the discharge pressure will be tapped out through a copper or brass pipe, and then it will be connected to the pressure gauge. And before connecting to the pressure gauge, there will be a curved structure like this on the pipe. So this curved structure like this, or a pigtail like this, or a U-bend like this is called as the siphon tube. In this video, we'll see the importance of having a siphon tube for any process pressure or temperature or any process measurement in instrumentation. When you go in front of an auxiliary boiler on board our ship, the pressure gauge tapping will be taken from the boiler, and this will have a curved structure like this, and then this goes to the pressure gauge with a cock or a small valve, and this structure is called as a loop, which serves the purpose of siphon tube. Now on a boiler, why do we have this curved structure? Most of us think that since hot steam is coming through this pipe, the pipe has to expand or the tube has to expand. So it's provided for thermal expansion. That might be a secondary reason, but that's not the actual reason why this is provided. The main reason why a siphon tube is provided is to safeguard the pressure gauge, just to avoid or prevent the pressure gauge, the Bowden gauge, getting damaged. Now let's see how does it prevent. With the pressure gauge here and tapping forming a loop, let's say that's the loop, and this tap from the boiler. So the hot water, let's say the boiler is 7 bar and the water temperature at 7 bar, we can refer to the steam chart, but for this example let's assume it to be somewhere around 140 degrees Celsius, and the steam will also be approximately at the same temperature. So let's say the steam is at 145 or something. So when this comes through the loop, the pressure gauge is safeguarded, or the pressure gauge remains intact. It's not getting damaged. If there is no loop, if this tapping is going to be straight from the boiler, no loop, just straight from the boiler, the steam or water, which is at 140 degrees Celsius, just goes and hits the Bowden, and then it might be a problem for it, or it might get damaged. Now, how does this loop prevent the pressure gauge from getting damaged? Let's assume this to be the loop. Alright, this is the loop. Now what I'm going to do is, before installation or during installation, I'm going to fill this loop with some water or process fluid. If it's going to be instrumentation panel, it'll be glycerin or glycol, sometimes water, sometimes mixture of both, And if it's going to be process oil, it might be lube oil. Let's say for the sludge pump it'll be lube oil, and afterwards, even though the lube oil gets leaked out, the sludge comes and occupies this place. The idea is to have some liquid in this loop. Now for a boiler, we always have some water filled up in this loop as shown in this picture. So as the steam comes through this, passage from the boiler, it heats up the water, or in turn the steam gets condensed. The superheated or dry saturated steam does not get in touch with the Bowden gauge of the pressure gauge directly. The contact is through the water, so the Bowden gauge is saved from getting damaged. That's the purpose of the siphon tube. Here is one more view of a pressure gauge tapping from a boiler, or let's say some pump or something. So here is the pressure vessel, and here is the pressure tapping from that pressure vessel. Let's say again a boiler. That's the most common thing we can easily understand with respect to shipping. So here the hot water or steam is there, and if there is no U-bend like this, you need not have a coil structure like this. It can be a U-bend like this, or even a pigtail. So this will always have some water in it, or during installation the installer must fill it with water or respective liquid depending upon the process fluid. With respect to steam and boiler, it is usually water. I'll just color it up. So here is the water. Now as the steam comes through through the boiler, it directly touches this water first, and then it might push the water up. So the water gets carried away, and there might be some air which remains over here. You can't purge out the air completely, so some air or something will be there over here, and this air gets inside this Bowden gauge and then gets compressed. So you need not worry, since you might be getting a question that if you have air, when it gets compressed, will the reading be perfect? Is that your question? If so, the reading will still be perfect because air is compressible, and that's why we have air compressors, and the pressure gauges measuring air, compressed air on board ships, give a perfect reading of air bottle pressure, which means air, how much ever it is compressed, does not affect the steam pressure. And it is this steam which is going to compress the air. So let's say we have a 7-bar boiler, and the air over here will get compressed to 7 bar, and thus the reading will show 7 over here. So that's how it will be. And you might ask a question, will the water get compressed? Of course you know the answer very well. Water is incompressible. It just transfers the pressure from steam to air. So that's the function of siphon tube. The pigtails or U-bends are also serving the same purpose.